Determine the real solutions to the system of nonlinear equations. Our system of equations contains x squared plus y squared equals 9 and x squared plus y minus 2 squared equals 1. So when I start a system of nonlinear equations, I like to draw a sketch of the picture first to get an idea of how many solutions I can expect. So usually I do a sketch that is very generic, just taking note of what type of equations I have. So in this example, the first equation is a circle, and the second equation is a circle. But in this particular example, because they're both circles, it's actually a lot easier to draw the graph, and I can get a pretty accurate sketch and maybe even figure out the solution quickly. So we have a circle. This circle has a center of 0, 0 with a radius of 3. The second equation has a center of 0, 2 with a radius of 1. So if we sketch these two circles, the center of 0, 0 with radius 3, I'll go 3 away from that center of 0, 0. And I get the first equation, the graph of the first equation. The second equation has a center of 0, 2, which is right here, with a radius of 1. So if I go 1 in each direction, I get this circle right here. And when we look for solutions to the system, we look for intersection points. So the intersection point of these two circles is right here, which is the ordered pair 0, 3. And that's going to be the only solution to the system. But I also want to do this problem algebraically to find the solution. And there are two algebraic methods that are typically used, and that is substitution and elimination. So if I'm going to use substitution, I'm going to choose a variable to solve for. We usually solve for x or y. But in this equation, because of all of our variables having a squared on them, I'm going to solve for x squared and substitute into x squared. So let me show you the substitution method. So with the substitution method, I'm going to take that first equation, x squared plus y squared equals 9, and I'll solve for x squared. So let's subtract y squared to get x squared equals 9 minus y squared. And we're going to substitute that in for x squared in the other equation. So that will give 9 minus y squared plus y minus 2 squared equals 1. And let's try solving this equation. Got 9 minus y squared. Let's simplify these parentheses. That's y minus 2 times y minus 2 equals 1. Still simplifying that multiplication, we would have y squared minus 2y minus 2y plus 4 equals 1. I can combine like terms to get y squared minus y squared. That'll be 0 y squared, or 0. Negative 2y plus negative 2y would be negative 4y. And 9 plus 4 is 13. But now that the squareds have canceled out, I have a linear equation, and I want to solve for y. I'll subtract 13. That's negative 4y equals negative 12. I'll divide both sides by negative 4 to get y equals 3. Then let's substitute that y back in to get the other variable, to get x. That gives x squared equals 9 minus 3 squared. X squared is 9 minus 9. X squared is 0, and x equals 0. So we get the solution 0, 3, using the substitution method. Well, that was the same ordered pair that we saw graphically. Now, I also said you could solve this with the elimination method, so let me show you what that would look like. So if we're going to use the elimination method, you want to decide which variable to eliminate. So looking at my x's, I have like terms. Both of them have x squared. On my y variable, I don't have like terms, and I won't be able to eliminate y. So with the elimination method, I need to eliminate the x. So I'll multiply a negative 1 on both sides of the equation, and I'm multiplying by a negative 1 so that my x squareds have the same variable with the opposite sign. So my first equation is unchanged. My second equation is negative x squared minus y minus 2 squared equals negative 1. Now with that elimination method, I'm going to add the equations together. The x squareds cancel out. We have y squared minus y minus 2 squared equals 8. 9 minus 1 is 8. So we've got some simplifying to do. Y squared minus, and let's expand this binomial, y minus 2 times y minus 2. You'll notice I put these big brackets on here in the multiplication, and that's because I want to make sure that I'm subtracting everything in this multiplication. So we'll save that subtraction for later, after we complete the multiplication. So if we multiply, we'll get y squared minus 2y minus 2y plus 4 equals 8. Got y squared minus y squared minus 4y plus 4 equals 8. And now I can distribute that minus, make sure it applies to every term. Got y squared minus y squared plus 4y minus 4 equals 8. Combining like terms, the y squared minus y squared cancels. We have 4y minus 4 equals 8. Okay, so we're gonna, now that the squareds are gone, we're gonna solve for y. We're gonna add 4 to both sides. That gives 4y equals 12. Divide by 4 and y equals 3. We've got the y coordinate of our solution. Let's substitute that back in to get the x coordinate. X squared plus 3 squared equals 9. X squared plus 9 equals 9. Subtract 9 and x squared equals 0. And we get x equals 0. So once again, we get the same solution, 0, 3, using the elimination method. Given the quadratic function in vertex form, address the following. We want to sketch the graph, use the graphing tool. This refers to my math lab. and we want to state the domain and range. We want to do that for this quadratic function that's in vertex form. F of x equals x minus 2 squared minus 16. So I mentioned that it's in vertex form. In vertex form is f of x equals a times x minus h squared plus k. That hk that you see is the vertex of the parabola. So if you have a parabola that is opening up like this, the vertex will be this lowest value here. And if you have a parabola that's opening down, it will be this highest point here. So that's very convenient when trying to draw the graph, knowing that vertex. So with our function being in vertex form, we notice that the h is this value after the minus sign, and the k is going to be this number that's either added or subtracted. So we can see that our vertex is 2, negative 16. So that's very helpful in sketching the graph. The next thing that's really helpful in sketching the graph is knowing whether your parabola is going to be facing up or facing down. And you can determine that using the value of a. Anytime a is greater than 0, your parabola faces up. Anytime a is less than 0, it faces down or opens down. So we look to the coefficient here. In front of the parentheses, we have a 1, and since a is equal to 1, and that's a positive value, we know that this parabola opens up. Now, most likely you're going to be completing this problem in my math lab, and so just knowing that it opens up isn't enough to use that graphing tool. So you'll need a second point on the graph. And in that second point, we can choose any ordered pair we want. An easy point to choose would be the y-intercept. So if we want to find the y-intercept, we would let x equal 0. So I'm going to calculate f of 0 to be 0 minus 2 squared minus 16. That's negative 2 squared minus 16. 4 minus 16 is negative 12. So we get a second ordered pair on the graph, 0, negative 12. The first one is that vertex 2, negative 16. So this will be enough for us to draw the graph. So when we're drawing the graph, we want to plot that vertex. We have 2 and negative 16. So I'm going to go 16 down. And I'm going to go ahead and count by 2 since 16 is quite a lot. So we're going down negative 2, negative 4, negative 8, negative 10, negative 12, negative 14, negative 16. So I need to go to negative 16, which is right here. And I'm going to have that second point being the y-intercept here. And parabolas are always symmetric around the vertex. So I know that I got that y-intercept at 0, negative 12. I'm going to have a mirrored point over the vertex here at 4, negative 12, and that kind of rounds out the shape of my parabola there. We have the sketch of our parabola using the vertex. and you want to get a second point. That second point can be any ordered pair on the graph. Then we want to state the domain and the range. Now there are a couple ways you can think about the domain. You can get the domain kind of analytically. This quadratic f of x equals x minus 2 squared minus 16. As I said, it's a quadratic equation because of the squared. A quadratic is a type of polynomial, and every polynomial has a domain of all real numbers, no restrictions. So analytically, we know that it has a domain of all real numbers, negative infinity to infinity. However, you do have this graph here, and you can use the graph to notice that, if you look at your x's, your graph covers all of the x's, starting from negative infinity going to positive infinity. So using the graph, you can also see it has a domain of all real numbers. For the range, we have a parabola facing up, and we found that vertex. So we can use the y-coordinate from the vertex, and everything above that, because it's facing up, will be part of the range. So the range will go from negative 16, including negative 16, to infinity. You can use the graph, or you can use your knowledge about the vertex and the parabola opening up. You can start with that y-coordinate of the vertex, and the y values go up from there. So that gives us a domain of all real numbers and a range of negative 16 to infinity. We want to graph the inequality. 3y is less than negative 7x. So this inequality is an inequality in two variables. And because it has two variables, we have to graph it in two dimensions. So there's basically a two-step process for graphing an inequality like this. You're going to start with the boundary. And to find the boundary, we're going to treat the inequality as if it were an equation. So instead of 3y is less than negative 7x, we treat it like 3y equals negative 7x. Now, sometimes the boundary is going to be included in the graph, and sometimes it's not. When you have a less than or a greater than, the boundary is not included. And when you have a less than or equal to, or a greater than or equal to, the boundary is included. So in this example, because we have a less than, that boundary is not included. And the way we indicate that in our graph is to draw a dashed line. So when we graph this boundary line of 3y equals negative 7x, we draw it dashed to indicate that that boundary is not part of the graph, is not part of the solution. So to draw this line, I'm going to rewrite it. 3y equals negative 7x. Let's divide by 3. We get y equals negative 7/3 x. Now the reason I rewrote it is because I wanted to write it in slope-intercept form. Y equals mx plus b. So because I don't have any number added here, I know the y-intercept, b, is 0, 0. And I have the slope of the line being negative 7/3. So that's going to help me find a second point on the line. So I've got my y-intercept at 0, 0. I'm going to go down 7 and to the right 3. Down 7 and to the right 3 gets me to this point. And I'm going to connect those 2 points with a dashed line. And that's going to give me my boundary line. Now that boundary line is going to divide up this plane into 2 parts. And one of those 2 parts is going to be shaded. So we've done the boundary. Now we're going to move on to the second step, which is to figure out the shading. Now when you do the shading, you have to figure out which side of this line makes the inequality true. So we choose a test point. There's only one rule with the test point. The test point cannot be on that boundary line. So I'm going to choose this point right here, 1, 1. That point is not on the boundary line. Most people like to choose 0, 0 as the boundary point, but we couldn't use 0, 0 here because 0, 0 is on the boundary line. Okay, so we're going to take that point 1, 1 and plug it into the inequality, the original inequality. That gives 3y is less than, I'm supposed to plug that number in, sorry. That test point of 1, 1. 3 times 1 is less than negative 7 times 1. We get 3 is less than negative 7. That's a false statement because 3 is not less than negative 7. So on this side of the line, we got false. We want to shade on the true side. The other side is going to be the true side. So we're going to do our shading on this side of the line. So we found all of these ordered pairs in this shaded region are going to make that inequality true. The ordered pairs that are on the boundary line are not included in that graph and not included in the solution set. Solve the exponential equation using the method of relating the bases by first rewriting the equation in the form b to the u equals b to the v. The reason why we like writing it in this form, b to the u equals b to the v, is because once we get it in this form, we're going to be able to simplify the equation to u equals v. And then we'll be able to solve the equation. So we want to do that with this example, 1 over the 5th root of 16 equals 2 to the x. So we want to rewrite it so the bases are the same on both sides. We have a base of 2 on the right-hand side, which clues me in to maybe trying to make the left-hand side have a base of 2. So the number 16, if I think about 16, I know 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16. So I can write that 16 with a base of 2. That's 1 over the 5th root of 2 to the 4th. And then I have this radical here, and what we need to remember is that radicals can be written as powers. So this is the same thing as 1 over 2 to the 4/5 power equals 2 to the x. So because we had the 5th root, we divide by 5 in the power. We had the 4th power and we still have the 4th power. And one last thing that we can do, we have 1 over, so we can use one of the properties of negative exponents and move this factor to the numerator. That would give us 2 to the negative 4/5 equals 2 to the x. So now we've written it in that form where the bases are the same. So we can simplify the equation and say that the exponents are equal to each other. That gives negative 4/5 equals x, and that's the solution to this equation, negative 4/5. Benjamin Associates, a real estate developer, recently built 205 condominiums in McCall, Idaho. The condos were either 2-bedroom units or 3-bedroom units. If the total number of bedrooms in the entire complex is 521, how many 2-bedroom units are there and how many 3-bedroom units are there? So this is an application of a system of equations. So we have that a total of 205 condominiums were built. So we can say that the number of 2-bedroom condos is X, and the number of 3-bedroom condos is Y, and we built a total of 205 condominiums, so X plus Y is 205. And then they give us the number of bedrooms to be 521. So in the 2-bedroom condos, we'll multiply the number of condos times 2, that gives us the number of bedrooms. And the 3 bedrooms times the number of 3-bedroom condos, and we can add those two together, and that should equal 521, the total number of bedrooms. So that gives us a system of equations. We're going to solve that system. You can do it with substitution or elimination. I think the last time I did this kind of problem, I used substitution, so I'll do elimination. So I would decide which variable to eliminate. Let's eliminate x. I want them to have the opposite signs, but the same coefficient. So I need a negative 2. I'm going to multiply a negative 2 times that first equation. I get negative 2x minus 2y equals negative 410. The second equation stayed the same. Now add the equations together. Negative 2x plus 2x cancels or eliminates. Negative 2y plus 3y add together to be y. And then 521 minus 410 would be 111. So we get the number of 3-bedroom condos to be 111. And then we can figure out the number of 2-bedroom condos by substituting this back in. That's x plus 111 equals 205. I'll subtract 111. That's x equals 84. Let's just double check. 84 plus 111. Okay, so my math is a little off there. That should be 94 Yeah, 94. So we have 94 two-bedroom condos and 111 three-bedroom condos in this new complex. Thank you for checking out my videos. Have a great day.